We have previously learned about the formation of ions. Now we will learn about ionic bonds. Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are, in fact, transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't you grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause the lesson and resume when you are done. Magnesium transfers its two valence electrons to oxygen, forming a magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses two electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming two chloride ions. The calcium ion is electrostatically attracted to the two chloride ions because the opposite charges must fully balance each other out. In all three examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, the charges must be balanced so that the resulting ionic compound has an overall neutral charge. Many ionic compounds do not just exist in a laboratory or in your chemistry homework. Sodium chloride is regular table salt. Sodium fluoride is added to some toothpastes to help strengthen tooth enamel. Ammonium nitrate can be used to fertilize plants. Although their real-life applications are very different, they share a few key properties. In this lesson, we will learn about the properties of ionic compounds. These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions. When we apply a force, it breaks the regular repeating pattern of oppositely charged ions, causing ions with like charges to come close to one another. The ensuing repulsion breaks the lattice structure. Sodium chloride, sodium fluoride, and ammonium nitrate can all dissolve in water, as we know. Or else we wouldn't be able to flavor our soups, brush our teeth, or fertilize our plants. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds. This is made possible due to the presence of free-floating ions. We can dissolve copper 2 sulfate in water in a beaker. Add a few drops of sulfuric acid. Place a strip of copper and a strip of zinc into the solution. These will act as electrodes. Using 2 alligator clips, connect one strip to one end of the mini light bulb and another strip to the other end to complete the circuit. You will see that the light bulb lights up. Hence, this solution conducts electricity. Following on the same idea, molten ionic compounds can also conduct electricity. The lattice structure is broken at high temperatures, and so the ions become free-floating. In summary, ionic compounds have high melting points, are brittle, and can conduct electricity when dissolved in water or molten due to the presence of free-floating ions.